In this video series, I'll be going over the system components to the Bosch Praesideo system. Our first component that we're going to go over is the network controller, which is the heart of the Praesideo system. At its base, it is the controller. It's the main controller for all of the system components. It acts as a standalone system. Once a NCO is configured, it no longer needs connection with a computer or a server of any kind. It does store the last 199 faults and call events that happen within the system. Those can be recalled with our logging viewer and logging server software. It controls the audio, meaning it controls dynamically all of the 28 audio channels on the system bus. It's also our alarm and message manager within the system. The NCO itself has the capability of storing up to 1,000 individual message names with a total record time in WAV file format of 3 hours, and that can be expanded to 12 hours if needed. It is the open interface and Ethernet kind of point in the system. It's the point where you would normally connect up a Cisco SBA 3102 or a Amex touch panel or a Crestron system. We also offer a Bosch solution to any kind of PC-based paging. It's called PC Call Station. We'll be getting into that in another video. It also is the power supply for the system components such as call stations, fiber converters. Anything you're going to plug into the system that's not an amplifier is essentially going to be powered off of the system bus power supply, which is located within the network controller. As far as audio inputs and outputs, we've got 4 audio ins and 4 audio outs. The first 2 inputs on the system are going to be switchable between mic and line input. The second 2 inputs are going to be line input only. And the outputs within the system offer 4, and pilot tone can be enabled for all 4 of those. DSP audio processing is available on every input and output within the system. 3 parametric filters, high pass, low pass, shelf filters, and also input sensitivity and output gain adjustments are available. Every piece of gear, with exception to a few pieces, has 8 supervised control inputs. Supervision meaning that we can actually supervise an open circuit, a closed circuit, a shorted, and essentially a break in the line. We do that by inserting 2 10K resistors within the line, one in line with the switch and one across the switch, basically giving us 10 and 20K. Is now our open and shorted within the contact closure. That way an open state is a fault and a shorted state is also a fault. The network controller itself is going to have 5 control outputs, but as you'll see in a moment here, not all 5 of them are freely available to be programmed. The first 3 are open, the last 2 are actually dedicated to fault notifications. 2 versions of the network controller, the 4401, which is an older version, which is no longer available and hasn't been available for a number of years. Probably won't see that one out unless you're on an old retrofit. The NCO-B is what's available now. Keep in mind that the newest version of the hardware, version 21.05, it will come with version 3.5 or higher, and it cannot be downgraded to a lower version of firmware. So if you're going out on a retrofit and it has and you're putting in a new network controller and the gear that's existing in the system has version 3.4 firmware, upgrade the old gear to match the 3.5 firmware rather than downgrading the network controller back to 3.4. Just bring everything up to the newer version. It has a 48 volt DC battery backup input that is also a supervised power input, and it's got a new processor, which is faster. On the front panel, we've got our LCD, we've got our rotary encoder / push button, and there's also a headphone socket. And not noted on the image here is a front-mounted speaker, which can be used as a monitor. We can actually pull up and listen to any one of the 4 audio inputs or 4 audio outputs within the system. On the back panel, we've got our control inputs. There's our 8 control ins. Now those are each supervisable. Keep in mind we do not recommend a common ground if you're running multiple contact closures to a location. Use individual pairs of wires for each contact. Our control outputs, you'll see that 4 and 5 are dedicated to fault alarm sounder and fault alarm indicator. Those are fixed functionality, meaning we cannot change that. Those are dedicated to fault statuses. Outputs 1, 2, and 3 we can dedicate and program to whatever you choose. Our audio inputs and outputs are available in both XLR and RCA ins and outs. They are both active at the same time. There's no kind of internal switch or jumper setting that has to take place. They're both just active. Also on the back is our system bus connector. This is an AMP F01 connector on the fiber and a 16 gauge copper bus lines that are basically used for power. And that's kind of all encapsulated within a hybrid Bosch connector. However, the fiber connector is a standard AMP F01 connector. Mains and backup power, that's our two inputs right there. You'll see it is switchable between 230 and 110 volts as well, and our 48 volt backup there on a Phoenix block. That is about it for our network controller. Our next piece of gear we're going to go over is our call stacker. Call stacker is basically going to handle any collisions that should happen within the Praesideo system. It does have 256 levels of priority, but if there is any kind of collisions, or if you are in the middle of a call and your call is stepped on, or if you're stepping on somebody else's call, essentially the call stacker is going to be able to play back that message or live speech in its entirety after that zone that you're trying to page to is free up. It's connected up to the system bus, only one node in the system, and we'll go over nodes here shortly, unless you've watched the network architecture video here. It's powered up from the system bus. It's only one node in the system, and you can have multiple call stackers in a system, which is actually it's not really necessary at most points, but some applications may need it. This will handle 8 recordings at the same time. That's 8 recordings and 8 playbacks at the same time. So very powerful little unit we've got here. And that's going to record the priority, the zones, the chime, the live speech, and any recorded messages that should play. So basically everything other than BGM is going to be recorded and automatically played back as available from the call stacker itself. 3 operating modes are available. Call stacking, which is essentially just handling collisions in the system. Time shift, which is basically also known as forced stack. If I'm in an area where I've got a speaker above where I'm paging from and it's going to feed back, I have the ability to force the system to record my live page, and then when I let go of the page button, essentially play back that page immediately, getting away from any kind of feedback issues. Time shift with pre-monitor, that's going to give me the ability to make my live page and then play back my page through my paging console, which has a small speaker located on it. It'll actually play back my speaker to myself, and then I've got a defined amount of time to cancel my message. So I can essentially make my live page, listen to it, either approve it or cancel it, and off it goes. It's got to play back everything in order as they came in within the system. It's got a timeout function built in, so we have the ability to basically cut off long messages. So we can set a timeout for 3 minutes. Also, we can set a timeout in the system for that if a call is locked up and it is recorded within the stacker, and that zone is attempting to page into is busy for a specified amount of time, the page is essentially just deleted. So if I've got a page waiting in stack for, say, 3 minutes, and I've got my timeout set for 3 minutes, essentially after 3 minutes that page is deleted, and I will have to make that live page once again. Time shifter, it's basically what we just went over, the no feedback during playback, and time shift with pre-monitoring, able to listen to the recording first, then decide and play or cancel it. Call station kit. Call station kit is a printed circuit board that can be used as a paging station, essentially giving you the ability to make a custom call station. If somebody was looking for a fireman's panel or maybe a wall-mounted or desk-mounted call station, what we can do is actually run fiber to one of these call stations, or even a Cat5 with the remote call station kit, and be able to build that into a small box underneath the table or in the wall, and use custom buttons, custom LEDs, and a custom microphone to actually build up our own call station. The same controls and connections are available within the call station kit, giving us the ability to use a dynamic microphone or a condenser microphone, control input for the PTT key. We still have the monitor speaker and volume adjustments. It still has the headset output, which our standard call station has as well. This has an external power supply connector, so we have the ability to power it externally, meaning backup power, versus our normal call stations, which don't have that external network, external power on them. This is going to give you the ability to have remote power basically for that. 3 status LEDs are essentially on the board itself, giving you the fault and call notifications as well as emergency notifications right on the board itself, with LEDs plugged into the header basically. Same supervision and speech converter and parametric filters are available on the call station kit as our normal call station. It's essentially the same call station that you'd normally purchase, except it's in a circuit board fashion, and still the connection up to 16 keypads for 128 total keys is available within our within the call station kit. Call station keypad kit, essentially going to get you 2x8 control outputs. Those control outputs are typically LEDs that are going to give you the zone status for selected, not selected, in use, and all that. 8 control inputs as well. That is your buttons to select zones and select macros. Basically, all the functions that a normal call station keypad would have, this is going to have that on a circuit board. Audio expander essentially is a expansion unit. It has the same audio inputs and outputs as the network controller. However, it does not have the TCP/IP input, nor does it have the front-mounted speaker mounted within it. It is just an expansion module, which is going to get you the control inputs, control outputs, analog inputs, and analog outputs. That's 4 in and 4 out, again in RCA and XLR. The control inputs are supervised, same as the network controller. However, the control outputs, you do have access to all 5 of the control outputs. And again, a system bus connection for redundant networks. This is not a power supply within the network itself. The network controller itself is the only power supply within the system, and this is powered via the system bus, meaning it's powered from the network controller. Fiber splitter. Fiber splitter is essentially going to get you 2 non-redundant tap-off points from the system bus. If I've got a redundant loop system and I need to tap off to 2 non-redundant areas, I can put a splitter in my line and essentially get a break off onto 2 separate fibers that basically T-tap off of my fiber. Those are non-redundant tap-offs. I do have a power limiter that I can enable for each tap-off point. There we go. Tap-off 1, tap-off 2. External power supply is available to power those 2 tap-off points. So if they are loaded down with external gear and I'm nearing the point where my internal power supply within the network controller can no longer handle the power load needed, the external network splitter is a way to inject additional power using those tap-off points. Our call station itself, let me get back into here. There we are. Our call station, standard, has a electret microphone, our push-to-talk key, our internal loudspeaker, which can be used to pre-monitor pages, and our 3 status LEDs. That's going to give you fault status, power status, live speech status, and also the emergency status within the system. Has a headset connection and an internal volume control for controlling the volume of that internal speaker. It also has a system bus connection. There's 2 options here. Since this is a remote call station, it is going to have a Cat5, which is going to be routed to our... Oh, let me double check that. Actually, this might have to be edited. This is a... Yeah, this is a call station. Our call station here, shown our fiber calls. Our fiber call station... Let me go back. Our fiber call station, as shown here, is essentially a network item. It does end up as a node within the Praesideo system. Comes standard with an electret microphone, a push-to-talk key, loudspeaker, a 3 status LED showing live speech, emergency, and faults, as well as power. Headset connection with volume control, and a system bus connection. There is 2 fiber connections on the rear of the unit, giving you the ability to insert this within a redundant network system. Supervision of the microphone capsule is available, has an internal compressor and limiter and an analog speech processor. It also has internal DSP, giving you the standard 3 parametric filters, high pass, low pass, and sensitivity adjustments. Connection up to 16 keypads are available. Here's our status LEDs and our call station LEDs, essentially showing you everything within the system that's going on, whether or not a fault is being indicated, whether or not the system is in the middle of a reboot, emergency status, live speech status, microphone active, power. Essentially, it's giving you the full functionality and visibility within the system in kind of a generalized detail. 2 different modes, emergency and normal class. A normal class priority call station is only going to have priorities up to 223. A emergency call station is basically going to be have full access to all the priorities, all 255 within the system. It also acts, if it is an emergency call station and it is a fiber call station, it can act as a backup for the network controller. There are some very special situations where this is required, and there are some special things that need to happen in order to make this into a backup for the network controller. In the event that this is used as a backup for the network controller, you will not have accessible to you the call station keypads. The only button that is essentially available to be used is the push-to-talk button. That will activate an all-call page at 0 dB, meaning full out on the amplifiers. However, if the network controller is down, it's nice to know you can still make a page. And this would only be needed if you do not have a redundant network controller in place. The keypads, up to 16 of them can be connected up with the system. Here's our keypad. Those are removable key label covers. Those just kind of pull off. You can fill out an Excel spreadsheet which has the keypad blanks, print that out, cut it out, and basically they just slip underneath those label covers there. Status LEDs are on each one of the buttons. Key covers are available. These are replacement light pipes. Basically, the light pipe on a certain key is removed and a new light pipe is pressed into place that includes a keypad cover within it. These are addressable units. Up to 16 of them can be connected with the system. There's a hex dial on the rear bottom of the unit where you can address the units 0 through essentially 16, and they are connected up with the call station via a ribbon cable. Numeric keypad is also available within the system. This can be used to lock down our network controller from external use, from unauthorized users. Password protection can be enabled, making it so if a user comes up to make a page on the call station, the entire call station that the numeric keypad is connected to, all of the connected keypads and the general call button are locked out until a username and password is entered into the numeric keypad. Once this is entered, you can enter in your zone and group selection. It's not used for any kind of BGM selection. It is only used for zone selections within the Praesideo system. And password protection can be disabled within this as well, where somebody could just walk up and type in their zone and make a live page. On the bottom of it, we basically just have our standard ribbon connections where we are plugging into other keypads. Brightness and contrast are also available to be adjusted within the bottom of the keypad itself. This is kind of important here. Our first keypad ribbon cable. This ribbon cable is going to come with our network controller. It is a very special ribbon cable. It is about 1/4 inch longer than the keypad connector that's going to come with our keypads. If you throw this ribbon connector away, you will not be able to plug in your keypads because that extra 1/4 inch is needed. So pay attention when you're opening up your call station. The call station is where that, in that box is where that ribbon cable is going to be located. Here's a nice shot of our 16 keypads on our call station. Keep in mind a numeric keypad is available to reduce that. Another version of call stations is our call station interface and remote call station. These are essentially remote units over Cat5. It's a 1-to-1, meaning one call station interface to one remote call station, or PRS CSR. We're dealing with the PRS CSI and PRS CSR here. Up to 1,000 meters, so we can go 1 kilometer over Cat5 with this CSI CSR combination. At that point, I recommend probably remote powering the system, and this does not, I repeat, does not account towards our fiber length when it comes down to how many nodes versus our system bus length. If you've watched the network topology video, we essentially go over our amount of fiber we can have in the system versus how many nodes we have in the system. Since this is a extension of a piece of gear, where that CSI is living, that is the only fiber that's counted within the system. This Cat5 up to 1,000 meters, that does not count towards our limitation that we're keeping track of. So essentially here our system bus length is at length, and then we've got our 1,000 meters on top of that, and it is not counted towards that. The CSI is the node in the system, so for you, those of you who are programming your system definition, the PRS CSI, or call station interface, is actually the point where you're going to add in that serial number into the system. Same amount of keypads we can have, up to 16 keypads, and powering from the system bus or externally powered. Now on the back of the call station itself, we're going to have a remote power input. Again, this is a 1-to-1, so if you've got multiple call station interfaces and remote call stations within the system, you're essentially going to have one CSI, one CSR. They're going to act as a pair within that system. Mobile call station, essentially what we've got here is moving a call station from point to point. What this can do here, notice we have connection supervision turned off. If somebody was to want the ability to move a call station from one point in a building to another point in a building, say they've got a front entrance and a rear entrance and they only want to have one call station active at a time, they could basically remove a call station and then plug in the other call station when they were working in the other location. So it's just an option, but one of the available options that it has. Same functions as the original call station, same LEDs, same contact closures, same lights on the front LEDs. Essentially, it is identical, other than the network connection to the system. It is generating an internal ISDN line within that Cat5 line, so it is not analog audio. It is still digital audio over ISDN, giving you the ability to run through multiple locations without getting any kind of interference from lighting fixtures or any kind of high voltage interference. You can see here, same status LEDs as the normal call station are available. And it is available as a normal or emergency call station. However, since this is not a fiber call station, it does not have the ability to be a backup for the network controller. Only the fiber call station has the ability to act as that. Two control inputs can be freely programmed within the CSI and on the call station itself. So if somebody wanted to have, say, a panic button on the wall near a call station remote or a PRS CSR, essentially they could run a contact closure directly into the back of the CSR on that power connector as well, and that dry contact closure to trigger some kind of event. That same contact closure availability is on the CSI as well. There's a shot of the rear here. We've got our Cat5 connector, our power connector, and the small RJ12 connector is essentially a programming port. We don't use that other than for at the factory during programming. On the CSI, you'll see our two system bus connectors, giving you the ability to insert this within a supervised ring topology type fiber system. System bus powering, either powered remotely or powered from the remote call station, or from the call station interface. There we are with an external power supply connected up to the CSI, and then internally we have connected a jumper to essentially choose external power for the remote call station. Our fiber amplifier, these are our fiber series amplifiers. There's 4 different versions, PRS-1 P500, 2 P250, 4 P125, and an 8 P60 available. Notice the model number here on our diagram here is still the 4428, however that has been updated to the 8 P60. Outputs are selectable between 50, 70, and 100 volts per channel. There is one output relay per amplifier channel, and those are actually on the rear Phoenix block along with the amplifier speaker output. However, they're not tied program-wise to those actual amplifier outputs. Those are freely programmable as volume control, system zone active, fault and emergency output relays. They're freely programmable to use as needed. 2 analog inputs. Those analog inputs actually end up on the system bus, meaning that any kind of input I should put into the system can be used globally within the system. Those 2 inputs can also be used as an AVC input, or automatic volume adjustment input. If I use the AVC, if I'm using AVC and I route my AVC microphone into my amplifier, all the processing for the AVC actually happens within the amplifier itself. Now that's going to help me in a way because I'm not using one of my 28 lines of communication. I've got 28 audio channels on my system bus. If I was to put my AVC mic on a different input within the system, that AVC microphone would have to be transferred over my system bus, taking one of my 28 channels. And if I've got 16 zones or 20 zones of AVC going on, I could start to eat away at my 20 available or 28 open lines of audio fairly quickly. So 2 audio inputs on the 1, 2, and 4 channel, 4 inputs on the 8 channel 8-channel amplifier. Built-in amplifier supervision for mains and backup power. The amplifier supervision for 20 kilohertz pilot tone you can enable or disable within the outputs. internal temperature supervision and connection supervision for any kind of AVC microphone that I should put in. Also a line input pilot tone detection as well. So if I am using this for an AVC system and I've got my AVC microphone plugged into one of the inputs within the system, I have the ability to supervise that microphone input. That way if somebody is in the ceiling working, they've cut my AVC microphone, I essentially get a fault within my system, and that'll be realized on the login view or login software, or even on the front of the NCO, or even the call station. I'll get a flashing yellow light, and I'll be able to detect what has happened from then. Output short circuit and ground short detection built into the system, and spare amp switching for 70 volt and 100 volt systems. And wire-free line supervision, and we will go over that essentially coming up here. Wire-free meaning that you do not need a return line back to the amplifier or any piece of gear to use our end-of-line boards. DSP audio processing, same audio processing as any other piece of gear that in our system. We've got our 3 parametric filters, our high-pass, low-pass, shelving filters, and output level control, as well as AVC level control available on our fiber amplifiers. Audio delay up to 1.5 seconds. Our front panel has our LCD display, rotary switch / push button, and a front mounted headphone socket. The headphone socket can be used as a monitor output from the system, giving me the ability to either monitor my 2 audio inputs into the system, and also either 1, 2, 4, or 8 audio outputs within that specific amplifier. All of our amplifiers have front to rear cooling, meaning that everything that's Praesideo related is going to be have the same type of front to rear. Control inputs, we have 8 supervised control inputs on the rear of the unit, as well as our mic line inputs, and our control relays, 100 volt, 70 volt inputs, outputs. The inputs would be the spare amplifier inputs. Our mains switch, our mains power, and our DC power input within the system. And that DC power input is supervised as well. And then our 2 system bus connectors. Obviously there's 2 again, giving us the ability to inject this within a redundant loop system. Here's a shot of our 8-channel amplifier on the rear. Notice our 4 line inputs or mic inputs. Same thing, 48 volt DC backup power available, mains power, and our 2 system bus connectors. Inside we've got our control board, our power supply, our output boards, our output transformers, and our Class D power amplifiers. In this image here, let me bring up a mouse here, you can actually see our switch right here. Our jumper is basically switching between 50, 70, and 100 volts here as far as our output for the amplifier itself. A little bit of our let me go back here. There we go. A little bit of a screenshot of our audio processing. Do not remove the 68 hertz filter. This is essentially just for the end-of-line boards. We don't want to take off that 68 hertz filter. Not like 70 volt systems use 68 hertz a whole lot, but we actually filter out 68 hertz because of our end-of-line boards and the frequency at which it's running on. Control inputs, same as your typical network controller or any other piece of gear. We've got 8 supervised control inputs. And our audio inputs on the Phoenix block. Those are electronically balanced. We do offer phantom power. Keep in mind it is a 12 volt phantom power. So if you're using these for any kind of AVC input, keep in mind that you're going to need a AVC microphone capable of running down to 12 volts phantom power, or have another external piece of gear convert that to line input or inject that phantom power for your microphones, but kind of an important one on that note. You can see on the back of our amplifier here we've got our loudspeaker outputs as well as our spare amplifier inputs. Now if I have, say, 6 main amplifiers and 1 spare amplifier, the loudspeaker out, as you'll notice on our spare amplifier, is going to route to our loudspeaker spare in on every one of my main amplifiers that the spare is going to cover. Essentially, I'm going to make a copper bus out of my on the back of my amplifiers using standard speaker wire, essentially. Loudspeaker out to spare in, and link that spare in on my top amplifier here up to the next spare amplifier input. What happens is when an amplifier fails in some kind of way that it can no longer reproduce sound, the spare in is automatically relay connected over to the loudspeaker out of the failed amplifier. What also happens is all of the audio that is normally routed to that main amplifier is automatically rerouted to output of the spare amplifier. Also, what happens at the same time is all of the DSP and delay settings that are in the main amplifier are automatically transferred to the spare amplifier, making it so when a main amplifier goes down, the end user or the facility essentially does not lose those delay settings or those DSP settings. We want to make it as kind of transparent as possible when an amplifier goes down. Standard relays, single pole, double throw relays. We have our common and our normally open and our normally closed. Battery backup powering, standard 48 volt DC. There's a number of manufacturers out there, typically in the phone field, who are making 48 volt DC power battery backup solutions that can be used with this piece of gear. Let's see here. Let's go over our fiber interface here. Our fiber interface is essentially a fiber converter. It's converting from our Bosch plastic fiber over to glass fiber. That's in single mode or multi-mode versions of the system. It is powered by the system bus, or it can be externally powered as well. It's going to have 2 supervised control inputs. That is on the node versions of the system. The nodeless version, or the PRS-FINNA, is basically a you can call it a dumb converter in a way, because it's just doing a simple conversion, converting from plastic to glass. The other types of converters, being the PRS-FIN and the FINS, are smart versions. They do have the 2 supervised control inputs, and they do end up as a node within the system. There we go, PRS-FIN, FINS. Those are multi-mode and single-mode versions, along with our contact closure and backup power. And then our nodeless version here, bring up the mouse here, our nodeless version here, the FINNA, it does not count as a node within the system again. Now that is, it's kind of critical when you're thinking of how many nodes. If you've watched the network topology video, essentially we talk about how many nodes you can have within the system. Now you've got 60 nodes to play with. You know, if I've got a high volume of fiber within the system, that's going to lower the amount of nodes I can have in the system. And essentially, the more nodes I can pull out of the system, the more fiber I can have. So using a FINA and multi-mode fiber is kind of a savior when it comes to large systems. Another piece of gear that we offer within the system is the multi-channel interface and our BAM, or basic amplifiers. The multi-channel interface serves as kind of the gateway to connecting to our basic series amplifiers. The basics are basically our low-cost alternative to the standard fiber amplifiers within the system. You do have front LED indicators giving you indication of whether or not the connected amplifier channel is functional or in fault mode. There is no audio processing or delay functions within the basic amplifier systems or the MCI. Now that is kind of critical when you're connecting up to a system that requires AVC, or ambient noise sensing. That is not an option within the MCI and basic amplifier systems. There is no headphone connection within the system. There's also isn't a local audio input as far as inserting to the system bus each amplifier is going to have a local audio in, but that local audio in is a low priority input and is directly tied to the amplifier's output. Now, that can be handy in a number of situations, but that audio input does not end up in any way on the system bus. The multi-channel interface itself has 14 analog outputs that will connect up directly to the basic amplifiers. 2 outputs of the 16 are dedicated to spare amplifiers, and it's one node within the configuration, which in a large system, if you're concerned about fiber length and you're trying to keep your node count low, the basic amplifiers are going to give you the ability to only have one node within the system and have a high volume of amplifiers connected up. You do have volume control per output, so you do still have the ability to do some adjustments and define some volume levels on each amplifier itself. However, automatic adjustments aren't available again. Built-in supervision for the MCI and the basic amplifiers themselves, and built-in supervision control board for the WLS2. We've got another video that is going to talk about our wire-free line supervision, and the WLS2 will be part of that video. 32 supervised control inputs. Again, no common grounds used for any one of those 32 control inputs, and 16 control outputs. Those are freely programmable between zone actives, volume overrides, emergency indicators, or fault indicators. Basically, you can program those 16 outputs as needed. The MCI itself can be powered from the system bus, or it can be powered up by the basic amplifiers as well. There's an internal jumper setting that you can set how it's powered up. The front of our MCI itself is going to give you our LED status for each amplifier. It's going to give you a green or a yellow LED indicators showing you essentially whether or not the connected amplifier is enabled, one, but whether or not it's in fault mode or functioning properly also is going to be noted on that. Our rear panel, here's our 32 control inputs, our 16 control outputs, our bypass in and bypass out. This is kind of an important function that this has right here. The bypass, as it stands, what it does is if the MCI itself goes into fault mode, not a connected amplifier, but the MCI goes down, I essentially have 14 channels of audio that it would take down at the same time because I've got 14 analog basic amplifiers connected. So the bypass in and bypass out is essentially an emergency input into the MCI. While the MCI is not connected up with the system or is in fault mode, whatever's coming in on the bypass in is essentially pushed out of all 16 of the connected amplifier outputs. Now, during programming of the network controller itself, we can push audio in an emergency out of one of my XLR outputs back into the bypass in on my MCI. Here's our connected 14 channels of amplifiers right here, and our 2 spare amplifier outputs as well. 2 system bus connectors, giving you the ability to insert this within a redundant ring networked system. 4 versions again available are 1x500, 2x250, 4x125, or the 8x60 amplifier. They are all Class D power amplifiers again, same as the fiber connected amplifiers. 2 operating modes with the basic amplifier itself. The amplifier, it can be used with the multi-channel interface or MCI. It could also be used as a standalone 70 volt amplifier. The reason for that is because it actually has a local audio input on it, so connection to the MCI is not required in order to use one of the basic amplifiers. Loudspeaker A+B switching. Essentially, we can do a Class A wire loop system. What that means is we can essentially have a type of self-healing speaker wired network. So if there was a break within my ring of speaker wire, it would essentially self-heal that speaker ring and give me a notification on my console and on my network controller or connected logging viewer and server, I would be notified that that speaker wire had been cut. However, my speakers in a Class A loop system would keep functioning. Spare switching, same type of spare switching on the amplifiers as the fiber amplifiers, as you saw before. And the basic amplifiers are not a node within the system. Now, this is important again if you're using a very large system with a lot of fiber or a lot of pieces of gear. The MCI itself is a node within the system. The basic amplifier and all 14 amp channels, along with those two spares, those do not count towards my total node count. Kind of an important one here. Built-in supervision, we've got temperature sensing, output overload sensing, short circuit detection, ground short detection, mains and backup power supervision as well, and our end-of-line WLS2 loudspeaker and end-of-line monitoring are available. And again, that's a separate video that we go over the details on that. Our front panel of the amplifiers themselves, we've got our LED display showing our main and backup power status, along with our little VU meters here on LED style for amplifier outputs. Again, front to rear air cooling. On the back of the amplifier, we've got our local audio inputs and volume controls located above those, a little dial. Those are local audio inputs, meaning those are automatically routed as a low priority input into the amplifier, and they are directly routed to the amplifier's output. If you were to plug a CD player into channel 1 of the amplifier shown here, if you were to plug a CD player in here, essentially whatever you play is going to come out that speaker output. When a page happens, meaning it would come in through this MCI port here, that's going to be a higher priority than the CD player input, and it would be automatically disable that local audio input and override it. Our 70 volt, 100 volt output here, our LED switch giving me the ability to either supervise mains or battery power sources. Mains inlet, mains switch, ground lift switch is available. It's also switchable between 110 and 230 volts, and it does have our 48 volt standard DC supervised input as well. Here's our connection point here. In this scenario here, we've got a number of amplifiers with fiber connections on them, and we'll flip over here to the same amount of amplifier channels, but a MCI version. This is our low-cost alternative, where we've got a single connection point into our network, meaning I've got one node in the system here, and I've got my connected amplifiers within the system as well. These are all our basic amplifiers. Again, I can have multiple multi-channel interfaces within the system, and here we see a high volume of zones, however a low volume of nodes. I've got 1, 2, 3, 4, 5 nodes within the system, so that's 5 out of my 60 nodes, and I have a high volume of zones available to be used. Some more examples here. So that's our multi-channel interface. The last little accessory that we have here, other than going through the actual accessories list here, is our CobraNet interface. Our CobraNet interface is essentially running on a standard CM1 card made by Cirrus Logic and Peak Audio. It is licensed for 4 audio inputs and 4 audio outputs. It runs on standard CobraNet, so we can interface to a number of other devices and manufacturers. It's used for, primarily in our system, it's primarily used to connect multiple network controllers together. The fact that network controllers can never look into each other, basically, over fiber, the only way to connect them is via TCP/IP and audio, in an audio stream, essentially being an IP audio stream, an analog stream, or in this case, a CobraNet stream of audio, essentially. So It is a node within the system. It does have our control inputs and control outputs. There is no EQ or level control within the system. It is simply an audio transport within the system. That's 44 kilohertz 16-bit mono. It's basically, actually it's 48, sorry, 16, 20, and 24-bit mono. It's essentially CD quality audio over a network, not over an IP, however, because CobraNet is a network-based audio. This can't be routed over the internet. If you need to route over the internet, we make a PRS-1 AIP1, which is the audio over IP interface that will transport audio over the internet. But if they need to essentially route audio over the over a network, the CobraNet interface can be used for that. Our front display basically has our LCD panel, again our rotary switch / push button, and our headphone socket. The headphone socket can be used to monitor the 4 CobraNet inputs and our 4 CobraNet outputs. No front mounted speaker on the unit, but again we can actually monitor that input and output. Control inputs and control outputs located on a device. I've got 8 control inputs. Those are each supervised control inputs. That is a available option, can be enabled, and our 5 control outputs within the system, and those are again freely programmable control outputs. We have a dual connection for TCP/IP or a network connection basically, so we can hook up to a redundant switch, and our 2 system bus connectors, essentially giving this ability to insert this within a redundant network again. That kind of concludes the general system components within the Praesideo system. There are system components available. Our network cable assemblies are available in a number of different lengths. We've got a 0.5 meter, 2, 5, 10, 20, and a 50 meter spool. Now keep in mind that if you've watched our network architecture video, 50 meters is essentially the longest distance you can have in between nodes in the system. However, we do offer a 100 meter spool of fiber as well, and that is to be used with our connector toolkit and our network connectors, which we sell in a pack of 20. Cable couplers are available as well. They're not to be used to extend a 50 meter cable onto another 50 meter cable, or a 50 onto a 20, giving you a 70 meter cable. Basically, that limitation of that 50 meters has to do with the latency within the system and the way that we supervise our fiber network. Key covers in packs of 10. Again, these are light pipe replacements within the system, giving you the ability to have kind of a extra layer of security over a key. Supervision board brackets. If you are mounting our end-of-line boards, this is kind of a snapshot. If you've watched the end-of-line board video, you've kind of got the details on this guy. But essentially, we have a supervision board bracket to assist in mounting these end-of-line boards, or speaker supervision boards, if you will, whichever you have elected to use within your system. Handheld microphone, we've got a couple different versions. There's the 9080 and 9081. Basically, the 2 different versions are going to have here we go. Our 2 10K resistors are basically built into the 9081 version, and when I was talking within the video here, we were talking about supervised control inputs. This is a great example of our supervised control input right here. Essentially, over here on the right-hand side, this would go into one of our control inputs on the network controller, on an amplifier, on one of my call station interfaces, let's say. If I'm connected up to a supervised control input, I've got a 10K in line with my contact closure, and then I've got a 10K across my contact closure. What this does for me is this gets me 4 different states. It gets me opened and shorted, which are now false, and then it gets me 10 and 20K, which my system is really looking for in order to take action. The 9081 comes with the PTT wired for the resistors built in, essentially. And then we offer the 9082, which is a gooseneck microphone, which is primarily used for call station kits. If somebody wanted to build a custom call station that was in a wall or in a desk, you could use the 9082, which is just a standard gooseneck microphone with a couple different mounting options. That essentially takes care of the system components within the system. There'll be other videos kind of explaining a little more detail onto a couple different programming options. Keep a look for them. Thanks.